left. Uh, I don't know the name because I'm not able to recall it. It's very tough. Okay, guys, let me know if you're able to see my screen. Okay. ठीक है. So, guys, shall we start? All right, perfect. So, Harshal, I hope you are recording this session because there might be some people who are yet to join. So, we'll start by this. So, the last class, like yesterday, we ended up with a point that since we are using n cross n vectors, so in this situation, a lot of space is required, right? For that n vector, n size array and n size events. That's why we need to like have an optimization technique or efficient implementation of the vector clock in such a way that this time complexity can be reduced. So for that, this Singhal Kshemkalyani differential technique came into picture. So see, what I will do, understand my point. I will skip this, I will skip this, I will skip this, and I will skip this. I will directly come to this diagram. Okay. Once I'm able to convince you how the diagram is playing the role, then as soon as I will start reading the text, you will by default get understanding of what it is happening. Okay. So I will give you direct implementation first, and then we will go with practical implementation. Is it okay to you all? Chalega? Sure. Let's go further. Okay, guys. So you got to know that this 100 1100 here, yesterday we discussed that how this points are plotted, correct? Now the thing is, एक बात आप मुझे बताना, ठीक है? You consider these 2 points. I'm drawing it for you. Just pay attention to what I'm saying. This is my one timestamp and this is my other timestamp. Okay. What is this? This is 100 and this is 1100. Now tell me one thing. See, this algorithm that I'm using, it is not a generic algorithm. Okay, it is for the scenario where it can be optimized. Use it. Where it cannot be optimized, there is no chance. Okay, this is not a generalized algorithm. It will work for every case. Okay, wherever we find such implementation where the number of messages sending or receiving is less, we can use this algorithm and reduce the complexity. Now, how to reduce this complexity? So you understand one point. Every time I am when like every time when I am sending the message, I'm sending the whole n cross 1 array. Is it correct? Yes or no? That means in the diagram, if you can see here, where is the diagram? Yes, here is the diagram. Okay. In this, every time I am passing the message, you understand this, that 2 comma 0 comma 0 is passed completely with the message, right? This timestamp is passed as a complete n cross 1 vector. You are getting this understanding? So my point is, why to send complete n cross 1 fact, like why to send complete n cross 1 vector? I just know that only this value is changing, correct? Only this value is changing. I'll just redo. Just a minute. Yeah, I know this very clearly that only this value is getting changed to 1. Correct? Hai? Correct? Hai? Or I can say, understand one thing. Okay, what I'm trying to write here. See this. This was my event one. This was my event one, which was 1 0. Okay, 1 0 0 and 0. Correct. This was event one. Abhi, forget about message sending. Forget about it. Okay, just forget about that this message is been sent here. Okay, the message jo hua hai, it is not happened. Can you tell me what will be the value of this node? Can anyone tell me what will be the value of this node? Well, I can, sorry, what will be the timestamp for this event?
0100.
0 1 0 0. Correct? Yes, everyone? Correct or not? Yes, correct. Now, what change I am bringing? See, this should have been the timestamp if there was no message passed. But since there is a receive event, what is my final result? My final result is 1100. एक बात सोच के बताओ, what has changed in this? If we compare this to, can anyone tell me what value has changed?
दोबारा बताना भाई, क्या पूछ रहे हो?
First value is changed, correct? First value is changed from 0 to 1. Okay, let's take it more properly. Okay, if I write here 3100, so what is changed right now? What is changed if I discuss between these two? What is changed? What you can understand? What is changed here?
First value.
Guys, please, yeah, answer me, because if you are able to answer, then you are able to understand. You should understand this point. This is very important. If you are actively listening, then you should be able to answer. That will help you to understand it more clearly. This is how I also learn. That's why I'm saying. So what is changing in this particular timestamp and this particular timestamp? This particular value, first row. Correct? What has been happening? My first column is incrementing from 0 to 3. Correct? Other than it, is anything else changing? Is anything else changing? No.
No.
So tell me one thing. Now, in this scenario, if I ask you, is it really important to send the whole vector or only that particular value that is actually getting changed? You
We
getting
can,
my
we can send that only the value which is changed.
correct? Correct. That is the point of discussion. We need to send only that value that is getting changed. In this situation, we will be able to solve our complexity. Now, I will make you understand how this will happen in real time. See, guys, I have 1000. This point I am discussing. I have 1000, and this is 1100. Correct. Now think of it. What I need to send? So I'll send two things. So I'll send basically a set of tuples of what is changing. So my set of tuple will comprise of like tuples, and each tuple will have two values. Okay. First is process. Which process is it coming from? And second, what is the I can say, what is the count on that process? I will write it as I. Okay, I is basically count of that process. Okay, understand this. क्या मैं कहना चाह रहा हूँ? If I write here 1,3, that means process number 1 is having the count to 3. This is what is written here. This 3. So when I will be coming to this point, okay, let's now remove this all. I will make you understand again. Okay, now let's remove
सॉरी
this
टू
all.
इंटरप्ट, रिकॉर्डिंग हो रही है ना इसकी, इस सेशन की?
हाँ, रिकॉर्डिंग हो रही है.
ठीक है, थैंक्स.
हर्षद, रिकॉर्डिंग हो रही है ना भाई? हाँ, हो रही है. Okay,
ठीक.
let's come again on this point. Okay, very slowly I'm trying to explain you. So my initial point is 1 0 0 and 0. Correct? Abhi, if there was no message sent, you also know what would have been the value? 0100. Correct? If no message sent. Abhi, if message is sent, my value is coming like 1100. That means what I am doing, I am sending 1 comma 1 as tuple. So 1 comma 1 means that process 1 is updated to 1. So what I will do in this particular value, I will look for process 1 and I will update it by 1. As simple as that. Correct? Understood this?
Yes.
Yes.
Yes. Understand on more broader side. Okay. Let's take it on more broader angle. If I write a tuple like this, I write 1 comma 2 and 2 comma 4 or 3 comma 4. Then tell me one thing, okay? If this is my initial, I need to like understand from you. If this is my initial timestamp, now what will be my updated timestamp in this case?
1100.
2140.
Okay, okay.
No,
One
sorry,
answer is
2100. 2100.
2100. Okay,
140, no?
2140. Someone is selling 2140. Any other one? Any other answers? Okay, so let's discuss on this too. So see, check what is this first. Tell me, guys. Tell me what is this first value. This is a process. What is the process number? And what is the second number? Second value, the count on this process. So I know my process 1 will be now changed to 2. That's what Sneha and other guy, I forgot, Ritik, I guess, told. So my process 1 converted from 0 to 2. Correct? सेकेंड वाले का तो कुछ डिस्कस ही नहीं, इसलिए वो यही रहेगा. बट माय थर्ड प्रोसेस गॉट अपडेटेड टू वैल्यू 4. So my third process I will update to 4, and this is how my number will be increased. Sneha, you understood?
Yes, yes.
Perfect. So this is how it will work, and this is the only thing that is complete technique, nothing more than that. Now we will together go along with this stuff in this whole implementation, and you will only tell that it was very easy to understand. Okay, I'll get a pencil. I'll get a very small version of it. Okay, so this 1000 we are able to understand it. Okay, now if event 1 comma 1 is passed, that means what I need to update? I need to update process 1 with value 1. So process 1 with value 1 updated, so it become 1100. Correct? Correct? Yes. Now this process will be initially 1200. Correct? Correct? ये आप इसको भूल जाओ कि this message has been received. So this will be 1200, but now we got an event where it is a receive event. So what is been sent from here? It is sending that process 3 will have a updated value of 1. That's why on third place instead of 0 I updated it to 1. Correct? Got it? Perfect. Now coming to the fourth process. Again, it will do the same. From here, now what I will be sending? I will be sending that my process 3 will be having value 2 that needs to be updated on third place here. And this is how 1320 is updated. Got it? Now from here, understand this thing. 0001, perfectly normal. But here 4 comma 1 is updated, and when we send it to here, it will say that you need to update your 0 value by 1 because I am sending process 4 with updated timestamp of 1. Correct? Now I will be coming, when I will be going from here, this is a bit different from what we are doing right now. This is a set of tuples with more than one value. How it came to be more than one value? Because you need to understand here the value of 0 is also changing and the value of 2 is also changing. Correct? Got it? भैया ये 3 का 4 होगा ही सही, because this is of the same process of P2. So this will work unconditionally. But what needs to be additional change that we provided in this set? So what it is saying, that process 3 should be updated to 4 and process 4 should be updated to 1, and hence we got 1441. Are you able to understand this? Yes or no?
Yes.
Yes.
Everyone? Perfect. Perfect. This is the end of Singhal Kshemkalyani's algorithm. Okay. Now since you understood this, I will read the text for you, and you will experience that like you are able to easily understand this. Okay. So it says, for today I will name this person as XY. Okay. Easy for me to say. So XY differential technique is based on the observation that between successive message sent to the same process, only a few entries of the vector clock are actually likely to change. Yes or no? Just answer yes or no. Just say yes or no if you are able to understand. Yes or no?
Yep. Yep.
Yes. When a process Pi sends a message to Pj, it piggybacks. Piggybacks means it attaches only those entries of its vector clock that differ since the last message of Pj. Correct? Yes?
Oh.
Yes. Why yes? Because if you see this, what is Pi and Pj? Pi is this, Pj is this. Now what will be updated? The only values will be updated who are differing from the Pj value. Pj is P2 value. Got
Right.
it? So this is what is second point. When a process Pi sends a message to Pj, it attaches, cut this and write attaches. You will able to understand. It attaches only those entries of vector clock that differ since the last message sent to Pj. Correct? Yes or no?
Yes.
Yes.
Guys? Yes. Perfect. Now, if entries I1, I2, I3, In of the vector clock at Pi have changed to V1, V2, V3, then we will include it as a set of tuples. Yes or no?
Yep. Yep. Right.
Yes. देखो अब कितना इजीली आपको समझ में आ गया. एक बार सोच के देखो, इफ आई वुड हैव नॉट विजुअलाइज्ड यू दैट ग्राफ, ये तो एक वर्ड भी समझ में नहीं आता. करेक्ट? You would have been confused between pi, pj, message passing and everything. So that's why I brought that particular graph before. Now when pj receives this message, it updates the vector clock as follows. Again the same thing, that vt of I will be max of coming message and the local message. It will be both. It will be the maximum of it, as it was being discussed in the previous only. There is nothing new. Thus, understand this point now. Thus, this technique cuts down the message size. Correct? जो 1 to n message size था, now it is converted into a single tuple for only that message. So the complexity is reduced a lot. So communication bandwidth and buffer size requirements, everything is minimized. In the worst case, every element of the vector clock has been updated to pi since the last message, and in this worst scenario also, we will get n size array, not n square. Correct? Because each tuple will be there. So in the worst case also, our complexity will be order of n. However, on average size of the timestamp will be less than n. Implementation of this technique requires each process to remember vector timestamp in the message last sent to every node. Understand this point. This is good. Direct implementation of it will result in order of n square storage overhead at each process. Yes or no? This line, who is not able to understand? It would be more easy for me. This line, who is not able to understand? Okay. अभी क्या कर रहे थे? If you remove this xy differentiate technique, remove it. Now, earlier, what was the problem? There were n processes, there were n events, and there were n like message passing and all the events that were happening. So order of n into n, that is n square complexity, was coming for space complexity. Correct or not? Yes or no?
Yes.
Yes. But now, after this X and Y person developed a clever technique that cuts down the storage overhead to each process to only order of n. And this process works in the following manner. So, guys, this whole thing that I'm not reading for you, but I am 100% sure what you understood is written here. Okay, you just give a thought using that graph. You will be able to point each and every line. If I start reading it for you right now, you will be definitely confused. I don't want to make you confused. You just give your own time. You just keep a graph with you. You just keep these points with you and try to map it, what you are understanding and what you are reading. You will be able to understand it and you will be able to write it in an exam also. Okay, so I'm skipping this at this moment, and the complete little here I am skipping because this is the complete algorithm that we discussed orally right now. Okay, is it clear to all of you? Is it
Yes.
okay to all of you?
Yeah, yeah.
Perfect. And this done. I'm actually done with all the things now. This particular last slide. This is kind of example that is provided. So this is how this Singhal Kshemkalyani's algorithm works and helps us. So I am done from this chapter. to be honest. There is nothing more or less in this. But yeah, I hope you guys would have gone through the PDF again. And if at any point of time you feel like you are not able to understand anything, I guess we have 15 minutes. I can give 15 minutes of time to discuss that thing. Is there anyone and with any of the queries or lack of understanding in any of the concept?
Right now, I'm feeling crystal clear. So, good night, Yash and everyone.
Perfect, perfect. Chalo, great. Thank you. Bye bye.
Good night.
Chalo, bye. Good night.
Good night. Thanks, Yash.
Thank you, brother.
Thank you, bhai. Thank you.